share. Okay.
كل ما أنت سوق لنا يا ولاد عزيزو
قلنا
لما في دويدي ما أنت سوق
So you see,
لنا يا ولاد
معاه غير مثال
okay.
متكن
نسيب
أوكي سر
نسوي
Okay.
عبد العزيز انت قرارك سوق كل اسم معاك لا هذا حكى هاسي هذا
حيوان بطر معاك لما هذين
فارماسي بويدي وفرصاش هذه لا قد جاهزة
Okay. We have started the time variant and time invariant system.
Nice
I'm
talking
muting you all. Okay, I'm muting you all. I'm muting you all. Okay, time variant and time invariant system. We have started it earlier, yesterday, and means last class. Today we'll see the stable and unstable system. We'll start from this one. So the system whose output is bounded for bounded input at every instant of time is called a stable system. The system whose output is not bounded for bounded input is called unstable system. Bounded means the signal which is finite. It is minus infinity to plus infinity. This is the bounded. Bounded signal is about DC value, sin t, cos t, ut. These are bounded value. So stable and unstable system. Stable system input is bounded and the output is bounded. Okay, that is called the stable system. Unstable system, output is not bounded for bounded input is called the unstable system. Okay, so yt is equal to txt. We take bounded input. Let's xt is equal to ut. So yt is equal to tut is equal to rt. Rt is the unbounded. So unstable system. And another one yt is equal to xt plus 2. Let's take the input DC values. Let's say 4. So 4 plus 2 6 bounded signal. So this is a stable signal. Another example xt is yt is equal to sine of xt. Let's say finite value. Sine has the finite value. We know sine the range of sine is -1 to 1. So the range of yt is equal to -1 to 1. So it is a stable system because the output is bounded. Bounded means it has a limitation. Okay. And another one, invertible and non-invertible system. The system which has one-to-one mapping between input and output at every instant of time is called the invertible system. Okay. Invertible system. The system which has many to one mapping between input and output is called non-invertible system. Okay. Oh, I think I will take your exam on the first part. Okay, signal, not the system. This sheet has two parts. One is signals part, another one is system part. Okay, this is the system, but I will consider only signal part for the midterm. Okay, only signal part. System part will
Okay.
be after the midterm. Okay, these things will be after the midterm, but I want to finish it. Okay, so that after the mid I can show you the maths. Okay.
Okay sir
So it is very easy for you. Just solve the problems. Solve the problems associated with the first part. Okay, the system which has many to one mapping between input and output is called a non-invertible system. Okay. So let's say xt, and this is xt, that means the input. This is what is the output. Xt 1 to b, 2 to c, 3 to a, 1 to 1. See, this is the 1 to 1. Okay, but here many to 1. The system which has many to one mapping between input and output is called a non-invertible. So this is invertible, this is non-invertible. Okay. A system which has one-to-one mapping between input and output at every state of time is called invertible system, and it is called non-invertible system. Okay, see here, yt is equal to x squared t. So if I take xt as 2, yt is equal to 4, x is equal to minus 2, yt is equal to 4. So many to one mapping. So this is a non-invertible system. See how you decide is it invertible or non-invertible by taking some samples. Okay, and another example, yt is equal to xt plus 2. Let's say xt value 0, 0 plus 2 means 2, 1, 1 plus 2 means 3, minus 1, 1. So 1 to 1. So this is invertible system. Okay, that is the thing. Non-invertible, invertible. So what is the invertible? 1 to 1 mapping. 1 to 1 mapping. Non-invertible, 1 to many mapping. 1 to many mapping. That is the non-invertible system. Okay, another important one, linear time invariant system. Linear time invariant system, that is very important one. Okay, LTI system. LTI system is both linear and time invariant. Linear and time invariant. See, a linear time invariant system is linear and time invariant. See, xt is the input, what is the output. So if I put the impulse signal delta t, then the response would be ht, that means impulse response. That is called the impulse response. For a LTI system, the output, that is the st, is called impulse response when the input is impulsive. Impulse response is used to show the characteristics of LTI system only. Impulse response is in time domain. Okay, it is in the time domain. Again, the system can be defined by transfer function. Transfer function is in frequency domain. Transfer function is used when input and output relationship is known to find systems characteristics. Okay, are you familiar with the transfer function? I don't think so. You
No,
have
sir.
you have not completed the control system yet, right?
Yeah.
Control system is left. Okay. Since control system is not completed, so you do not know the transfer function. Okay. So let me tell you what is the transfer function. Okay, transfer function is actually, let me draw you something. Let's say this is RT, that means input. This is CT, that means output. Okay, this is system. This is a system. It has a input RT and output is CT. Okay, so the ratio of output by input. If I convert it to the frequency domain, if I convert it to the frequency domain, by what? Frequency domain by Laplace transform, by taking the Laplace transform, then I will get what? I will get CS by RS. Okay, CS by RS. This CS by RS known as the TF, that means transfer function. Okay, this CS by RS known as the transfer function. So transfer function is the Laplace transform of output to the input of a system. Okay, this is the ratio of output signal to the input signal of a system. If I convert it to the time domain to frequency domain, then I will get the transfer function. Okay, so it is in the frequency domain. The system can be defined by transfer function. Transfer function is in frequency domain. Transfer function is used when the input and the output relationship is known to find system characteristics. Fourier or Laplace transform is used to go to frequency domain. See, that is the way. So I will show you Fourier transform here in this course to understand everything. Okay, so it is a very fundamental thing to understand engineering concepts, engineering maths, Fourier transform. Okay, the signal status has been changed time to time. So for this we need to know the Fourier transform. Okay, so it is a system, linear time invariant system. We need the Fourier transform to find the output. Okay, see, transfer function is the ratio of the output and the input of a system in frequency domain. See, output by input. Output by input is the, so Fourier, if we use the Fourier, then it would be H omega. If we use the Laplace, then it would be Hs. Okay, so we can use any one, either Fourier transform, neither Laplace transform. So Hs transfer function, this is the output Ys, input Xs. So Ht, if we, let's say it is in the time domain, so Laplace transform, after doing the Laplace transform, we'll get the Hs. Okay, so it is Yt in the time domain, so after doing the Laplace transform, we'll get the Ys. Xs in the time domain, sorry, xt in the time domain and xs in the frequency domain. Okay, for non-LTI system, non-linear time invariant system, we can't find impulse response or transfer function. Impulse response is fixed for each system, so it is a fixed for each system. Another important term is the convolution. When ht of a linear time invariant system is known and input is given, then we can find the output by using a mathematical tool known as convolution. So it is a convolution sign. Yt is equal to xt convolution of ht. Okay, we convolute these two, xt and ht. Then we will get the output. Okay, when ht of a linear time invariant system is known and input is given, then we can find the output by using a mathematical tool known as convolution. Okay, so we can find the output by using the convolution. Yt is equal to xt convolution of ht. This is the convolution sign. So yt is equal to minus infinity to infinity x tau h t minus tau into d tau. So this is the convolution formula. Okay, this is the convolution formula. Okay. So this is the convolution formula. So linear time invariant system, we have many other things to know for about this system. Okay, so I will stop here, but let's discuss the initial parts for the midterm. Okay, so we have started
Okay, sir.
from the signal. Okay, we have started from the signal. What is signal? It is a description of how one parameter varies with another parameter. Okay, one parameter is vary with another parameter. Okay, that is the signal. Example, a voltage changing over time is an electronic circuit, brightness varying with distance in an image. So these are the example of signal. Okay, and some signals are there like this, amplitude, this is time. Okay, this is a impulse signal, delta t. Another type of signal, sinusoidal signal. It is a position p of point p of t y. T is the time, y is the amplitude. Okay, and signal Classifications are there. How many types are there? Signal types. We have seen that how many signals are there. Continuous time, discrete time, energy input, power signal, even an odd signal. Various signals are there. Okay, and some logics are there. Some basic signals are there, like what is the unit step signal, what is the impulse signal, what is the RAM signal. You should understand all these. Okay, and continuous discrete time signal. This is the continuous time signal. This is the discrete time signal. Okay, just look at the signal. You should be able to tell what kind of signal it is. Okay, and this is the deterministic and non-deterministic signal. Okay, so you can determine the signal type, what would be the output, and non-deterministic means you cannot see the output. And even an odd signal, if it satisfies the condition, then it is even, otherwise it will be odd. And periodic and aperiodic signals are there also. Periodic signal, non-periodic signal. Energy and power signals are also there. Okay, real and imaginary signals are there, and even an odd signals are there. Even signal, odd signals, some examples are also there given. We have completed all properties, even the non-signal properties. Some examples are given, so you should look at the examples so that you can solve the problems in the assessment, the mid assessment. And average value of the continuous time signal area, average value, all things are given. Okay, some examples also are given. And energy and power signal, energy and power of continuous time signal, that is the CT signal. And some signals are there. Some basic signals are given here. Types of signals, like this is the impulse signals, delta t. Delta t is the impulse signal. This kind of signal is called the unit step signal. This kind of signal is called the ramp signal. And this kind of signals are orthogonal, parabolic. Some other types of signals are there. Signum functions are there. What is a signum function? And unit rectangular function, triangular function. Okay, some examples. So your middle would be up to this, up to the page number 25, up to page number 25. Okay, up to the page number 25, your midterm. Clear?
Okay, sir.
Okay, so I think it is enough, because I'll give you the maths, actually, maths. I'll give you 6 math, you have to answer 4. Okay, you have to solve 4 math. I'll give you 6 maths.
Okay.
Okay.
Okay, sir.
So you check this one, and let me find out the book. Actually, I have the hard copy of the book. Okay, but I'll show you. I'll give you the book name in the messenger. Okay, in the messenger group. Okay.
Okay, sir.
At this moment, I don't have this book at my hand. But later, I'll give you in the messenger, so that you can download or you can take the book from the library. Okay, for
Okay,
the
sir.
practice. Okay. So I think this is enough for the midterm. And let me again tell you, the midterm 10 mark would be the assignment, 10 mark assignment, 10 mark assignment, mid assignment, and 10 mark would be the viva, 10 mark viva. Okay, before the viva, submit the assignment. because I'll check you submit or not. The assignment would be the admit card for your Viva.
We understand, sir. Okay.
Right?
Admit card. Okay.
I think you are familiar with it because if
Yeah.
you complete it all at due time, then you'll be relaxed.
Okay, sir.
Okay, okay. So
Okay, sir.
that
Okay.
is my saying so far, and I will give you the book name for downloading it from the net.